So we're now going to start looking at a hypothesis test for the population mean, more specifically when the population standard deviation is unknown that we discussed in the previous video. So what that means is we're going to dive in here further is we're going to start seeing t pop up instead of our z. Now if you remember, there are 5 different steps that we're looking for when you do a hypothesis test. Our first step is always our hypotheses. We're going to have a null hypothesis and an alternative hypothesis. Our null hypothesis will always have that equal sign in it. Here we're using mu to represent our population mean because we always are talking about a mean when we have quantitative data. So that's how it's different than when we learned about p, because p was for a categorical variable. This mu0 that you see here, when we're actually doing a problem, this will be a number. So for example, I might have a null hypothesis that mu equals 20. So we will have a number plugged in for mu0, but that number will change based upon what problem we are doing. For our alternative hypothesis, we'll have the same symbol of mu and this same number. All we have to do is figure out what sign goes between them. Are we trying to see that the mean is different from 20? Are we trying to see that the mean is less than 20? Or are we trying to see that the mean is greater than 20? Or possibly phrased as, has the mean changed? Has the mean decreased? Has the mean increased? Right? There's different ways we could phrase that, but we're going to read that in our problem to figure out which sign we will choose there. For our second step here, it's our decision rule. And that is when we are going to reject the null hypothesis. And I always say to believe then the alternative hypothesis. If our p-value or probability that we calculate is less than alpha, which was our significance level. So now we know when we're no longer going to believe our null hypothesis and we will believe the alternative hypothesis instead. The conditions that we're going to look at here are very similar to what we had in the previous module for the first 2. We still need to have our relatively random and unbiased sample, that we're not taking our sampling method in a biased way. We don't have biased questions that we're asking. All of those types of things we learned in module 2. Then we either need to know that it's normally distributed or have a picture to look at that looks normal, or have a sample of at least 30 that we're taking. I put in this third condition as a little reminder. Here we're not going to know the population standard deviation. But what I want you to realize is although we will not know the population standard deviation, we will know the sample standard deviation. So that is, we still will have a standard deviation. It's just now based upon our data instead of the entire population. And the reason I have that as a third condition is when I go over here to my test statistic, that is why I'm going to see t show up instead of z. And our t will be calculated as our sample mean minus, and I put a mu sub 0. The main reason why that mu 0 is there is because whatever number I have up here in the null hypothesis is what's going to go down here for my test statistic calculation. Then we're going to divide by s, because we don't know that population standard deviation, over the square root of n. In our previous video, when we talked about the t distribution, there was this extra piece of information I mentioned called degrees of freedom. And so the degrees of freedom for this t is our sample size minus 1. And again, that number is just helping us figure out how much trust I can put into that sample standard deviation. Once we have our test statistic, we can get a p-value. Our p-value here we will actually be getting from Statcrunch instead of our table. Now why? Our table was a Z table. I don't have a Z anymore, so I can't use that table for this. But I will actually still draw the picture to go along with it to try to understand the idea of what Statcrunch will be doing to give us our p-value. From there, we can go back up to step 2 to make our decision, and then step 5, interpreting what we found. As I mentioned, we're going to be using Statcrunch, so I have some directions here on what we're going to be doing in Statcrunch. So we will demo those for our example. And for that, those are the 2 different ways to do that. So let's go ahead and look into an example here. We will do some old stuff before we dive into doing the hypothesis test itself. All right, so reading through our example, I try to pull out sort of the important pieces as we're reading through it and label any numbers that I can. So in 2015, the mean house price in the United States was about $214,200. Okay, it says it was a mean. So I have 2 different symbols for mean. We have mu, our population mean, and y bar, our sample mean. Well, looking at that it says it sort of was the mean house price in the U.S. in 2015. It doesn't say it was only calculated from like 50 houses or anything. So this number I'm going to think of as sort of my mu, or more specifically here, my mu 0. We would like to assess if this value is higher in 2017. Higher in 2018. So if I think about my goal, I want to see if mu is greater than $214,200. Okay. In order to test this, we took a random sample of 150 houses. So that's going to be my sample size. And found the mean price to be $216,400. Well, this number was based upon just those 150 houses. So that's going to be my sample mean, with a standard deviation of $31,700. Now again, this number is just coming from those 150 houses. So that's why it's a sample standard deviation and not a population standard deviation. And it also tells us that house prices are generally skewed right. So I have an idea about the shape of my data. So first, looking into some older stuff here. So using our appropriate rule, either Chebyshev's or the normal curve rule, or again sometimes referred to as the empirical rule, we're going to describe individual house prices that happened in 2015. So first, let's talk about which rule. So should I use Chebyshev's or the normal curve empirical rule? Well, it tells me that house prices are skewed right. So that means the normal curve rule is going to be out. So I am going to need to use Chebyshev's rule. So I'm going to draw out my sort of number line that I'm going to use here. And then from there, we're going to go up to 3 standard deviations out. The mean I'm going to use was based upon 2015. So this is going to be our $214,200. My standard deviation, well, the only one I got to use is the 31,700. So each of these steps is going to be 31,700. So I'll start with my $214,200, subtract off $31,700, and we should get $182,500. Subtract it off again, so subtract off another $31,700, and we get $150,800. And subtracting it off one more time, we get $119,100. Now going in the other direction, we're going to be adding the $31,700. So starting at our 214.2, add the $31,700, and we get $245,900. Add it on again, $277,600, and add on one final time, $309,300. So that's just first doing the math. And again, the math would be the same whether it was Chebyshev's rule or the empirical rule. Just how we can interpret those is different. So when we go out 2 standard deviations, so from the 150 to the 277 number, this is at least 75%. So I can say then that at least 75% of houses in the U.S. have prices between that $150,800 and $277,600. And just to be specific, this was in 2015. Now when we go out 3 standard deviations, what percent do we get? So what we learned was it was about 90% or more. That's at that 3 standard deviations out. Or we could say then that at least 90% of houses in the U.S. have prices between our $119,100 and our $309,300. All right, so that's something a little bit older. But now looking at our problem, what are our hypotheses of interest? Or basically I'm asking you, what is HO? What is HA? Well, since I know price is a quantitative variable, I'm going to be using mu as my symbol. Our null hypothesis has that equal sign in it. The alternative sign we have to figure out by reading the problem. So if I go back up here, I actually sort of already labeled this sign. We want to see if this value is higher in 2018. So we want to see if it's higher, so we chose that greater than sign. Higher than what? Whatever it was. It was $214,200. So this goal that I wrote up here is really just my alternative hypothesis that I'm writing up there. Now the null hypothesis, again, always has that equal sign, and it's always going to have that same number in it. So those are going to be our hypotheses. Now to go back to something a little bit older as well, we want to talk about what a type 1 error would mean in the context of our problem here. So first, let's remember what a type 1 error is. So a type 1 error happens when we reject the null when the null hypothesis really is true. That's the idea of what a type 1 error is generically. But now I need to put that in the context of the problem. So if I reject the null, what that really means for me is I'm going to believe that the mean house price has increased. That's what sort of rejecting the null hypothesis would mean to me. But that's not actually true. So when it hasn't increased. So that's our error part. All right, so now that we know what that error means, what would be some possible consequences if we did actually commit a type 1 error? All right, so what might we do if we believe that the mean house price has increased? Well, so for example, if I want to sell my house, so I'm going to list my house possibly at too high of a price. Now, why do I say too high of a price? Well, I think the mean house price has gone up, so I would probably list my house for a high price. Now, why I say too high? Because the house prices really haven't gone up. So I'm going to probably list my house for too much money. So one thing that could possibly happen then, right, I don't sell my house. I might end up having to reduce the price. And I'm not going to get as much money then as I thought. So those are some possible consequences that could happen if we commit a type 1 error. All right, now we're finally going to be doing the hypothesis test using a 1% significance level. So that's telling us then that our alpha is going to be 0.01. As you can see here at the bottom, I already have my Statcrunch output that I'm going to need, but we'll talk about that more when we get there. All right, so my first step is always to do my hypotheses. Now technically, we already have those written down here in part B, so I'm just going to recopy them down here. But if I hadn't already done it, this is where I'd be thinking through what my hypotheses should look like. So there's our step 1. All right, for step 2, that's our decision rule. So we're going to be using that alpha that we just labeled. So we're going to reject our null hypothesis and believe the alternative hypothesis if our p-value or probability is less than our alpha, which here was 0.01. All right, for step 3, we're going to start with those conditions. So I'm first going to just list them, and then we'll check them. All right, so our first one goes back to the sampling method. So let's go back and read our problem. So it says, in order to test this, we take a random sample of 150 houses across the United States. It's not maybe really a lot of houses, But was there anything biased about how I sampled those houses? Not what was given to me. So I don't know of anything that was biased here. So I don't have any known bias. Next, I either know it's normal or have a sample of at least 30. Now, I actually know it's not normal, right? It told me it was skewed to the right, so that first part is definitely not met. But remember, that's an or. Or sample at least 30. How many did I sample? I sampled 150. So even though it's not normal, it is at least 30 because I sampled 150 houses. Is my population standard deviation unknown? Yeah, I didn't label sigma here anywhere. I did have a sample standard deviation, but I did not have the population one. So that's correct, but I will go ahead and label for myself here that I had 31,700 as my sample standard deviation. All right, then we can do our test statistic. And first, I'm again just going to write out the formula before we plug the numbers in. And then let's make sure we know what numbers we're going to plug in where. So y bar, we already have as our $216,400. We then already have our mu 0, because remember this number is whatever number shows up in our hypothesis, so that number will come down here. S, we just labeled. N, I also just labeled. So I already have all my numbers to plug in here. So our y bar was our $216,400. Our value in our null hypothesis was $214,200. Our sample standard deviation was $31,700, and our sample size was 150. Doing a little bit of an in-between step here, that ends up being 2,200 over 2588.29. And then after completing all of that, I get a t of 0.85. All right, next for step 4 is when we're going to calculate our p-value. Now normally when we had a z, this is where we would draw our picture. And so I'm going to go ahead and draw our picture here because remember, t looks a lot like z. It's still centered at 0. I can still sort of put my scale on here. Our t that we just calculated was 0.85. That falls about here. Then this is where I would first ask if it's a one-tailed or a two-tailed test. So if I go back up to my hypotheses, I am only looking in one direction. More specifically, my HA tells me to look for a greater than. So I'm going to shade then everything to the right of that number. But now my p-value I'm actually going to get from Statcrunch here. But notice I gave you two sets of output, so we got to make sure we're looking at the right one. What's the difference between the two? It's looking at that alternative hypothesis sign. This would be our one-tailed test that actually matches what we have up here. This would have instead been a two-tailed test. So if instead we would have shaded in both directions and had to go over here as well, this would be the set of output that we would use instead. So we're going to use the left output. I'm actually going to go ahead and cross out that second set of output so I don't accidentally use it. So our p-value turned out to be 0.1983. Going back up to step 2, is that less than 0.01? It is not. So we will then not reject our null hypothesis. We will not then believe the alternative hypothesis. So then let's see how that makes us write out our interpretation. So I always start with my alpha level. And then whether I reject it or not tells me if it was or was not statistically significant. This time we did not reject, so this not continues into step 5. So it is not statistically significant. So there is not statistically significant evidence. To support. And then finally, the last part is the alternative hypothesis, but in words. So there is not evidence to support that the mean house price in the U.S. in 2018 is higher than that $214,200. So there's not evidence to support that. More specifically, not statistically significant evidence to support that. Why I want to emphasize that part is if you go back and look at our sample mean, well, it is higher than the $214,200. But you have to keep in mind we only sampled 150 houses across the entire United States. So even though that sample mean was higher, it isn't enough higher for me to say that the mean house price of all houses in the U.S. is higher than $214,200. All right, lastly, even though the example here is finished, I just want to demonstrate how I got that output in Statcrunch. So remember, the directions for Statcrunch are here in our notes, right, where we talked about it. I'm actually going to demonstrate the summary option here. So where we're going to go in Statcrunch, I'm just going to open a blank Statcrunch screen. I'm going to go to Stat T statistics now. Because remember, we have that population standard deviation being unknown, one sample, and then with summary. Here, I'm just going to enter in that summary information that I was given. So I need my sample mean, or my Y bar, which was $216,400. My sample standard deviation was $31,700. And my sample size was 150. So they're just the numbers that we get from our data. Now, I'm going to leave this hypothesis test button clicked. Later, we will do a confidence interval, so you'll see what that looks like later. And then I just want to make my hypotheses look like what I had in step 1. So the number I have in my null hypothesis was $214,200. My alternative hypothesis sign we chose was the greater than because we wanted to see if the mean house price had increased. Once I have that, I'm going to hit compute, and that's where you're seeing the output that you have, where I just rounded some of those numbers. Now talking through those numbers then a little bit better and where we saw them show up. So there's our sample mean that I entered. Here's our hypotheses. The standard error you see show up. It's actually this bottom number. That's our S over the square root of n, is at 2588.29 number. You see our T of 0.85 show up there as well. So these first numbers you can kind of see match the calculation that we did. Then the p-value is not a calculation we did just use Statcrunch to get that number. Now something to be a little careful of is the smaller the sample size, you will see more of a discrepancy or different numbers between z and t. So I'll just actually show you here, even though our sample size is 150, there won't be a drastic difference, but you'll see a little bit of a difference here in Statcrunch. So if instead I would have accidentally gone to the ZStat menu, the main difference that's happening here is that you're seeing it's just labeled as standard deviation instead of sample standard deviation. So it thinks that's my population standard deviation. So you will get slightly different looking p-values, but you'll notice that everything else looks the same. Okay, so you will get a slightly different p-value if you use a z, which can end up affecting your answer, especially if your sample size is smaller than the one that I have here. Right, so hopefully you feel pretty comfortable with that. Make sure you feel good with using the Statcrunch to get the p-value there as well.